So we have a 3 by 3 matrix, and we want to find the inverse of this matrix. We can do this by using matrix row operations. What we do is to firstly set up what is called an augmented matrix, which is basically two matrices inside one. We have our initial matrix on the left side, and on the right side we have the identity matrix. And from here we use row operations to try and obtain the identity matrix on the left side. But any row operations we do on the left matrix, as we transform it to the identity matrix, we also have to do the same operations to the right matrix. And once we have the identity matrix on the left side, what matrix remains on the right side will be the inverse matrix of our initial matrix. So let's attempt this method with our matrix A that is shown. There is generally no particular right order of row operations to turn our original matrix into the identity matrix. There can be a number of different paths that you can take. But here to start with, we can subtract row 3 from row 1, and this will give us a 1 in the top left corner. So looking at each number in each row, 2 minus 1 gives us 1, 4 minus 2 gives 2, and 1 minus 0 leaves 1. And we remember to do the same row operation with the right matrix, where at this stage the only change is 0 minus 1 giving us negative 1. Now for our second row operation we can subtract row 1 from row 3. We can see that the subtractions done here give us a 0 in the lower left corner of the left matrix. For a third step, we can multiply the second row by 1/3 to give us 1 in the middle position of the left matrix. Now we can multiply row 2 by 2 and subtract it from row 1. This will give us the 0 that we want in the top middle position of the left matrix. And in the right matrix, 1 and negative 1 will remain the same in row 1, but the 0 becomes negative 2 over 3. So now after 4 steps, we can see that we only have one column remaining to deal with in the left matrix. For a fifth row operation, we can multiply row 3 by minus 1, which gives us 1 in the lower right corner of the left matrix. For the next row operation, we can multiply row 3 by 2 over 3, and then subtract from row 2. Now we just have one final row operation to perform, which from where we are is to multiply row 3 by 1 over 3 and then add to row 1. So now we have the identity matrix on the left, which is what we were aiming for, and what remains on the right is the inverse matrix of the matrix we started out with on the left. So by using row operations, we have found the inverse matrix of our initial matrix A.